Hello all, welcome to Robopreneur. Today in this session we'll have a brief introduction to IoT. So yes, so IoT stands for Internet of Things. So let me read the definition first. So IoT stands for Internet of Things. It refers to the scenarios where network connectivity and computing capability extends to devices not normally considered computers to generate, exchange and consume data with minimal human intervention. So that's a very big description. So let's try to break it down. So network connectivity and computing capability extends to devices not normally considered as computers. So it means that it is extended to devices like sensors or other low-end devices like microcontrollers, and the data is exchanged and consumed with minimal human intervention, which means humans have a minimal intervention in the exchange of data. That means the exchange or processing of data. So now we'll see some of the fields of applications of IoT. So one is self-driving cars. So they are also known as driverless cars. So they use the data from the cloud, and depending on that they'll detect the positions of obstacles, and they will the cars try to move away when there is an obstacle, or reach a destination once the destination is given. So all that is done by self-driving cars. And the next one is smart cities. So we'll just discuss two features in smart cities. Let's say we want one of the feature of smart city is automatic parking system. So automatic parking system is like, suppose if there is a place where so let's say 100 cars are allowed to park, and already 50 cars are parked. So this information is broadcasted to all the cars that are heading towards that parking space, and depending on the space available, the cars can go and park. Suppose if 50 cars are available, 50 parking places are available, they can go and park there. Or if let's say all the 100 are over and the information is sent to the cars, so they can avoid going there and maybe somewhere else. That's one application. And the other application is air quality control. Let's say there are sensors put in different places, and they give data. Let's say one of the sensor gives the data about carbon monoxide, and the other sensor gives the data about the present in the ppm present in the air. And so this data is sent to the cloud, and depending on that, it is classified as polluted or non-polluted or free healthy air or something like that. So these are just two applications of smart cities. There are many applications like this. And the next field of application is wearables. So wearables these days are becoming very popular. So this wristband and all that come under wearables. So the health condition of the person who is using it, let's say his pulse rate, or let's say his blood pressure, so all that is displayed by the wearables. And the next one is smart home. So smart home is where the person can control the appliances in home from mobile, or let's say this Alexa, or this voice command like Alexa. So there can be buttons in mobile by which clicking on the buttons, the lights can be turned on or off, or maybe uh, by saying, like, say, hey Siri, or hey Alexa, to turn off the light. So these kinds of things can be done in smart home. So these are just four of the applications of IoT. There are many other applications. Now let's see the projected IoT market. So as you can see, in 2015 it was 15.41 billion, and by 2025 it's 75 billion. You can observe that it's exponentially growing. So the number of devices connected to IoT are like increasing voluminously. So now let's see what are the components present in IoT. So every components or whatever is involved in IoT can be classified into four parts. One is sensors, the second one is gateways, the next one is cloud, and the next one is user interfaces. So in the sensor category, we can actually combine sensors and microcontrollers in that category. So where the complete data collection is done and sent to the next step, that is gateways. So gateways do some kind of processing to the data whatever they receive and send it to cloud. So that kind of processing can be as simple as just filtering the data for every 5 to 10 seconds, or maybe or any other let's say taking mean of some values, or any other computation, complex computations also. It can involve complex computations also, and that data is sent to cloud. So cloud is a set of servers, set of computers where all the processing is done, and then that is sent to the user interface. So user interface can be mobile or laptop, where the data from cloud can be visualized in different forms. So the cloud can be of three types: private cloud, public cloud, and hybrid cloud. So private cloud is relevant is to a particular organization whatever is using that. So it's a customized, completely customized. And public cloud on the other hand is completely the opposite. That is, it's available to everyone. So popular public cloud platforms are Amazon Web Services or Microsoft Azure. So these all are etc. So these are just an example. There are many other public clouds. And hybrid cloud is it's made by using a few features of some of the features of public cloud, and some customized features, adding some customized features to it, and that's how the hybrid cloud is formed. Now these four components are actually classified in many ways, but there are two ways which are much easy to understand and much popular. So that is layered classification. So 3-layered and 5-layered classification. So the 3-layered classification has perception layer, network layer, and application layer. So in the perception layer, sensors and microcontrollers, they come under perception layer category, and in network layer, gateways, routers, and communication protocols like Bluetooth, BLE, Wi-Fi, all that come under network layer. And the application layer, the cloud servers and the what are the end devices, all that come under application layer. And 5-layered architecture is a more broad way of classifying it. So in that, the second layer, network layer, is exclusively for the communication protocols like Bluetooth, Wi-Fi, BLE, whatever it is. And the fourth layer is application layer, where this layer consists of the area of application, like say smart city, or maybe smart home, or maybe smart grid, whatever application is there. And the last one is business layer. So this business layer is where the data analysis is done. So like graphical analysis, or maybe result analysis, whatever it is. So these are the two layered classifications in IoT. And so IoT is not just software, it involves both hardware and software. So we will have a brief discussion of the hardware used first, and then we will move on to the software. So the first one is Arduino Uno. So Arduino Uno is the more popular board, is a very popular board. So it has analog and digital pins, and it has power supply pins, 5-volt power supply pins. So and there are some PWM pins, so pulse width modulation, which is used to generate a continuous time signal. And the digital pins, they are used to generate a digital signal or discrete signal. And the next one is Raspberry Pi. So Raspberry Pi is a single board computer. It has a lot of pins, like it has a lot of features like micro SD card and USB power, HDMI ports, camera port, and Ethernet port, USB port, and GPIO pins also. So Raspberry Pi is more like a computer. And then of course Raspberry Pi supports different communication protocols like Wi-Fi, Bluetooth, BLE, etc. And another one is ESP32. So ESP32 has different versions. This is one of the versions. So in this version there are more GPIO pins. That is, as you can see, there are 36 pins, out of which most of them support both digital and analog signals. So as you can see, this is PWM symbol. So almost all the pins support PWM, and it supports Wi-Fi, Bluetooth, BLE, and many other these and other communication protocols. And microcontroller communication is also possible with ESP32. That is, by microcontroller communication I mean UART, SPI, and UART, SPI, I2C communication. So all that is possible with this one. And the other one, this is another variant of ESP32. This is camera module. This comes with camera and SD card holder. So here, as you can see, the number of pins are less because most of the pins are used for the camera, for supporting the camera functionality. So that's the downside of it, but the benefit of it is you can actually take pictures, or maybe you can do some image processing also with this ESP32 cam module. So now that we have discussed the hardware, let's move on to the software. That is a let's move on to the software. So Platform IO is the software which we'll be using. So we will discuss from the process of installation, and from that is from the very basic, and we will check with a simple program whether the installation is correct, and then we will do one more activity. Let's start it. So for getting Platform IO, we actually need Visual Studio Code to be installed. So Visual Studio Code, I think most of you might be aware. It is I'm sorry. So Visual Studio Code is a software which should be installed before we install Platform IO. So in order to install Platform IO, go to this extensions tab. It's loading. Now in this extensions, you can just type Platform IO. The icon will be loaded. Yes. So here is the Platform IO icon. Now if see, since I have already installed, for me it's not showing anything, but if it's not installed, like you can see here, for other extensions there will be an install option available. So when you click on that, the Platform IO will be installed. So in my case it's already installed. Now I'm just going to here. Now once it is installed, we'll just have a quick overview of that. So I am just opening PIO home. So it's just opening now. So this is the home page of Platform IO, and as you can see here, you can create new project. You have options for creating new project or import Arduino project which is existing. So all that options are available. And one more thing, so here are the list of projects whatever are created. So these are the projects which I created. Like this, whatever projects you create will be available in this list. And then we can see this one. So this is the option where we can see whether our device is connected or not. So right now nothing is connected, so that's why the port number is not available. I will just connect the device and we will see what is changed here. So I have connected just now. I am just refreshing. Now you can see that the port number is available, that is /dev/tty USB 0. Now I am removing it again and click on refresh, and that's gone. So this is the place where we will see the device whether it's connected or not. And yeah, so now what we'll do, we'll just create a new project and we will do this simple program of hello world, and then we will do one more activity where we will send the data to a open source cloud called ThinkSpeak. Okay, so let's start by creating the project. Now let me scroll. No, not scrolling. So let me go to home page again. So now I'm clicking on new project. So here you can type the project name. I'm just typing as project 1, and then we can select the board here. So as you can see, this platform IO supports 1500 boards, which is a very huge number. Now we can actually type the name of the board also, ESP32. So let me try typing it again. So wait, yeah, so ESP32. So here ESP32 dev module, I'm trying to search it. Yes, so ESP32 Espressif ESP32 dev module, yeah, this is the one which we'll be selecting. So this is the board which we are selecting, because we are using ESP32 board, so that's we will select this, and I will let the framework be Arduino, and we will just save it in the default location. I'm clicking on finish. So it will just take a few seconds of time to create the project. So it will just keep downloading the dependencies, and it will just take some time. Yeah, so now the project is created. Now let's go to the project 1. So yeah, so this is the project which I have created just now. This is project 1. Now here there are, as you can see, there are many folders, many directories inside that. The directories which we are concerned will be mostly with src and platform io.ini. So src, so in the src directory we will have this main.cpp where we'll write the code. Of course, if you have to import from different files, if your code is longer and if you want to import different files, so then you can create file here itself, and you can name it according to whatever functionality it is, and also all that is also possible. Now here this is void setup and void loop like in Arduino, and the other one is platform.ini. So let me open this. So now here platform is Espressif 32, that is what we have selected, and board is ESP32 dev, framework is Arduino, and whatever extensions we are going to we are going to add, all that is done in this platform io.ini. So now we will write a very simple code now, that is hello world. We'll just print the hello world, and we will see the output. So here is main.cpp. Now let me initialize the serial monitor. Serial.begin. I'm choosing this as 115200. You may choose that as 9600 also. It's up to you. Now what I'll do, I'll just print hello world. And I'll just add a delay of, let's say, 1 second. So this is just to check whether all our installation is correct and it's working now. So I'll just save this, and yeah, let me first, yeah, so let me just upload it directly. We can upload or we can build and upload. Since this is a very simple code, I'll just upload it directly. So now I'm uploading it. So it'll just take a few seconds to start uploading. Yes, so it's uploading now. So all the dependency files, it's compiling all the dependency files. Okay, this is just warning, you can ignore. Yeah, so here it's showing an error, please specify upload port. So this error, the reason is I have not connected my board here. So I'll connect the board, and there is one more thing which should be done. So here we should actually specify the monitor speed, so the baud rate. So monitor speed equal to 115200. So by default it takes 9600. So this should be the same as the one whatever you have mentioned in the code. So I have mentioned 115200 and I'm doing that here. Now let me upload it again. So now I made sure that it is connected. Now I'm uploading again. So it'll just take a few seconds. Yeah, so now it's uploading. So again it's compiling all the files. So now it's connecting. Yeah, so now it's writing the code in the memory. So now it's successfully uploaded. Now let's go to the serial monitor and view. We should be getting hello world for every 1 second. So I'm going to the serial monitor and let's see. Yes, so it's executing the task. Yes, so now you can see hello world is being printed for every second. So this means whatever our installation is perfect. So this is just to check whether our installation is perfect. So now that we are done with this, now let's go ahead and do the activity, that is sending data to open source cloud, that is ThingSpeak. Now let's do that. So you can actually create a new project and write the code there. Right now I'm just terminating this program, but right now I'm terminating this program, and I have just the code already. Now I will just print this code there. I'll just copy and paste it there. We'll discuss this code before uploading it. So let me copy and paste it. Let me do it. There is some issue here. So I'm copying it and I'm pasting it here. Now let me comment out the previous code. Yes, so Yes, so now I have uncommented this. Yes, so this is the code which we will be using to send the data to ThinkSpeak. So here in this case, the data whatever is there, that's a very simple data. That is the LED state. LED state is being will be sent to ThinkSpeak. Now, don't worry about the squiggly lines once we include the library. Right now we have not included it. So once we include it, the squiggly lines will disappear. But here I have just used LED pin 25, as you can actually use any of the GPIOs which are available. I have used 25. So, and then ID password, and then let's go to ThinkSpeak first and see how we create a channel and how we get this right API key and all. Let's go there. So I'm opening the browser. Yes, so this is the ThinkSpeak. You actually have to create an account. It's a free account, you can do that. Now let me go to the channel settings. So initially when you open, there will be no channels. You'll have an option to create a new channel. So I have already created a new channel. So once I created it, so this is how it looks like. You'll have private view, public view, channel settings, and API keys. So in the channel settings, I have just put field 1, label 1. You can name it. Suppose if you are taking temperature data, you can take temperature and whatever it is. So this is channel settings, and here is the API keys. Since we are sending the data from microcontroller to this cloud platform, this is the we need write API key. For reading data from ThinkSpeak, we will use read API key. We'll learn more about that later, but right now just remember that we need write API key to send data from microcontroller to ThinkSpeak. So we will just copy this and paste it in the code. Your API key will be different. So yes, so I have used this key and I have pasted it there, and here is the private view. Let me clear the channel settings and see. Let me clear the previous readings, whatever are there. So now that it is cleared, let me go back and see. Yes, right now there are no readings. So like as I was saying, it will just show the state of the LED, whether it's on or off. So we will be sending the state of the LED once in every 30 seconds. This is a random time which I have chosen. You can choose lesser time or more time. But one thing is like there is one limitation, that ThinkSpeak needs at least 20 seconds to properly send the data. Otherwise, the data points will be missing. Anyway, so now this is void setup. So where we will be connecting to Wi-Fi, and then I have declared the LED pin, that is pin number 25 as output, because it should glow, or it should be toggling there. And then here we have we'll see that this is where it will be connecting to Wi-Fi, and once it is connected, the state of LED is printed alternatively. Once it is 1 and once it is 0 for every 30 seconds. So x equal to 200. Why this 200 and all we'll discuss later in much more detail. But right now here is the increment of count, and if it is even, the LED will be glowing, otherwise it's not glowing. So this is a very simple activity. The basic idea is to show how to send the data to cloud. In this case ThinkSpeak, which is an open source. And last thing, we have to include the library. So here you can actually, like as you have seen in the platform IO home, you'll have libraries. So from there you can add, or you can add the .ini file. You can add it directly in the .ini file. So let me add this directly to the .ini file. Now I'm going there and I'm adding it here. So now I have added the library dependency. This squiggly line should go, but yeah, that's not a problem. It will go. Once we compile it will go. Now this is a simple LED circuit. I have connected pin number 22 to positive of LED and negative to ground of microcontroller. So this is a simple circuit. So now let me connect it to the microcontroller. Now I have connected, and yeah, as you can see, the squiggly line has been disappeared. Now I'll upload this code. Now I'll upload this code to microcontroller. Let me upload it. So now I'm uploading it. Yes, so it's executing. So it'll just take some time. So all these are dependent files. So yes, so now it's linking. And in the code we have put some debug message actually to check whether we are able to upload it or not. So if the upload is correct, we will see channel update successful message, and if there is any error, it will show that problem updating channel. So let it complete uploading first, and we'll go to serial monitor and check this also once it's done uploading. Yeah, so it's uploading. Yes, so now it's done uploading. Let me go to serial monitor and see. So I've clicked on serial monitor. So it's just taking some time. So yeah, so it's trying to connect to Wi-Fi, and once it is connected, channel update is successful. You can just see the number of times. It's just the count number. I'll just show the output on the ThinkSpeak as well as on the board. Right now 1 is uploaded. Let me check. So it will just take some time. Yeah, so 1 is uploaded, and you can see the LED glowing, and in a few seconds it will turn off, and 0 will be uploaded. Let's observe. Yes, right now LED is off. Now we can see the 0 coming up here in a few moments. Yes, so you can see the time stamp also. So initially it was on, and then it was off, and we can see 1 0, and this keeps repeating because the LED keeps toggling. So now again the LED has glown, and in a few moments there will be an update in ThinkSpeak. Yes, you can see that it's moving between 0 1 0 1. So that's it for this session. I hope you now understand the basics of IoT, and you have got a good introduction to IoT, and we'll continue with more exercises, more activities, more fun activities in IoT, and in the process learn more about IoT. Thank you.